Now, this is the PEL 103 logger. It's used to check the energy consumption, basically log the energy consumption of equipment. And basically energy, as you run your equipment, you're able to see how much the equipment is consuming. We are connecting the voltage. You have the voltage connected here. Then you have the um, what we call the current CT, current transformer, being connected at this point. The current transformer basically picks the current, the voltage picks this voltage, clips pick the voltage, so that at the end of the day, we are able to calculate power, which is in kilowatts or watts. That means that is voltage times current. If you check here, we have the voltage being logged. This is the line to line. This is the power that we're getting. And this is the demand, kVA. So at the end of the day, we are multiplying current times the voltage to get power. Currently, we are running the pocket machine, which is basically consuming 5.9, going up and down. It keeps going up and down because another machine is connected, which binds from the pocket machine. We are supplying to another machine, which binds the the springs that have been pocketed now to another form, which now goes to make matrix. That's why we have the fluctuation up and down. We can connect the same machine um, to a laptop here. We have its software. PL, we can be able to monitor from the computer, and we can actually set up the machine from uh, the computer itself. It's taking a while to load, but it's loading. So, meanwhile, if we are to stop the pocket machine there, you'll notice that, for example, if we may check out the circuit breakers, I'll switch off the circuit breaker, then you'll notice there'll be a drop in the consumption. I'm switching off the circuit breaker for one of the machines. Notice what is happening. We switched off. Notice now we are not going to the 5, to the 6 that we are going to. We are talking about a stable 4 because now it is one machine running. I'll switch it on again and you see what happens. Now the machine has been switched on. Of course, right now the power consumed is small, but once you switch on the machine fully, it comes on. Now the laptop is loading, and now we are here. Uh, we can check the machine. We're able to start it up. We'll start it up using the USB. We are going to next. It should detect the instrument automatically because it is connected. We check it out again. We are here, it has detected already. We have this blue tick here, meaning it has detected the machine. Uh, if you can check now, we can come to the real-time data where we're able to see the voltage being supplied and the current. Notice that we've gone down because now the machine is off as we are talking. Now we have the phasor diagram, which gives the current rotation, the voltage rotation, and the power rotation, which will be about 120. Now the current rotation is giving us a question mark because the machine is not running. Now, what is the power being consumed? Right now we are talking about line 1 consuming 0.47 and the total is 0.710 because this is idle power. The machine is not running. Now, these are the same values that we'll get at the logger. If we check the logger, those are the same values we are getting. We're getting 0.7, that is what is running. And this is idle power. Thank you for watching that. And we do this. This machine basically is used for large consumers, but of course there are smaller gadgets that you can use, and you can use this actually to check how efficient is your equipment. For example, an equipment could be rated, say, 10 kW. Or let us use a simple example of what we call, let's say, a blender. A blender could be rated at 1.5. But as you run the blender, you realize it consumes more. So that is what this machine will be able to tell you what you are running in real time, what you are consuming in real time. But this is an industrial machine that normally we use for industry. The rating, the voltage rating is above 1,000 volts, the same with current. So you're able to measure large power and you'll be doing well. So um, I'm Richard, and Richard is an energy auditor licensed by EPRA. And basically, what we do is energy audit, try to ensure facilities, homes, and consumers basically reduce their consumption at the end of the day. Now, I want us again to focus at the machine. Now, I'm going to switch off again. Now, we'll want to remove the base load so that we are consuming zero. Now, I've switched off one machine that was basically heating glue. Notice we've gone to 37. That is what should be. Now, when you're not using a machine, please ensure it has been switched off anytime. Now, this is the other base load for the other machine. I'll again switch it off and notice uh, these are part of the losses, but we expect it to go even lower because there's nothing being consumed on that line except a bulb that I can say that is running on the same line. So basically, this will help you to understand where and how you are able to save. The essence of this, make sure you save, make sure you understand where and how you consume energy. Thank you so much.